You're still asleep at this hour. You! Wake up! You're going to be late for class again. Me, I'm gone.
Good morning, class. Operator, what is this? Change this. These are not my class suits. Thank you. Now, class, in our previous lesson, we talked about Newton's first law of motion. Today, we are going to be talking about Newton's second law of motion. Do you know what that law is? Let us hear that from Sir Isaac Newton himself. Okay, sir, what is your second law of motion?
Observed from an inertial reference frame, the net force on a particle is equal to the time rate of change of its linear momentum.
Thank you. Did you understand that, boys? I guess not. Let me try to explain that myself. Okay. To understand Newton's second law of motion, there are some concepts that you need to know very well. Inertia. What is inertia? Inertia is the resistance of an object to a change in its state of motion. What does that mean? Let's think of an object, a train. A stationary train will want to remain stationary unless you apply a force acting on it. What keeps it stationary? Inertia. Let's apply a force. Now, a moving train will want to keep moving unless you apply a force acting on it. Let's do that. Now, inertia has some properties. And one of the properties is mass. Inertia is directly proportional to mass. The higher the mass of the object, the higher the inertia. The lower the mass of the object, the lower the inertia. Well, I hope you got that, boys. Class, now let's take a look at an example. We have this object. When I release it, it falls. Why? Because of gravitational pull. Now, let's look closer. As you can see, we have weight, which is the gravitational pull, and which is equals to mass times gravitational acceleration. Now, that force, gravitational force, is not the same everywhere. It changes from planet to planet. We're going to take the same object and try it out in the moon. Yeah, in the moon. Operator, take us to the moon. We're in the moon. You see that man? Neil Armstrong. Hello? He can't hear me. That is the first man to land on the moon. And I'm the first Kenyan to land on the moon. Anyway, class, we are going to try the same thing we did on Earth, here in the moon, gravitational force. We're going to take our object and we're going to release it and see what happens. Now we have the object. Very slow. Why? Because the gravitational force on the moon is not the same as on the Earth. Here it is less powerful. That is why the object falls down slow. Now we are going to try the same thing in Mars. But before we leave, since we are the first Kenyans here, we're going to place our flag here. Operator, change that flag. Now take us to Mars. Welcome to Mars. Boys, we're going to do the same thing here on Mars. We're going to take our object and release. As you can see, it is a bit slower than from Earth, but a bit faster than on the moon. So what can we conclude from that, boys? We can say that gravitational acceleration on Mars is faster than on the moon, but slower than on Earth.